Good morning, guys. Today we're going to continue talking about limits. All right. So on your last quiz, you guys were quizzed on finding limits, looking at a table, looking at a bunch of numbers, and then looking at a graph. All right. So now what we're going to do is we're just going to look at the function itself and be able to figure out what the limit is without graphing it or without plugging it into a calculator. All right. So before we do that, I'll do the simplest form first as this little property. That says that the limit of b, which is some constant, as x approaches some number, all right, is always equal to b. All right. So, for example, put it in terms of not having a variable. This is the actual property. All right. If I had the limit of 7 as x approaches 10, it doesn't matter what x is approaching. The answer is just whatever this is right here, which is 7. Just like this was b, the answer is b. This is 7, that's 7. Now, why is that the case? Well, if we think about it, what we just talked about with graphing, by looking at graphs, what does y equals 7 look like? Y equals 7 is a horizontal line going through 7, correct? Right? There's y equals 7. Well, if I'm approaching 10 or any other value, it doesn't really make a difference. As I come from the right and I come from the left, what's the y value always going to be? It's going to be 7. It doesn't matter what x value I put in. All right. This does not matter. It's any constant. It's always going to be 7. So if I did the limit of 10 as x approaches 1,000,000, the answer is 10. The limit of 8 as x approaches 2 is 8. It doesn't make a difference. If there's no variable here, it's just a constant. The limit of a constant is a constant. That's basically what it is. The limit of b is b. The limit of 7 is 7. It does not matter what x is approaching. Okay? All right. Now, for all other ones, the first thing that we are going to do when we are trying to evaluate a limit is we first will check to see if substitution works, which means in this case, we have the limit of x cubed as x approaches -5. Whatever x is approaching, in this case, -5, we're going to plug in for x. All right. So you get -5 cubed, which happens to be -125. That is my answer, -125. The limit of x cubed as x approaches -5 is -125. Just substitute directly into the problem. All right. So for this one, we have the limit of 5x squared plus 3x plus 1 as x approaches 2. Go ahead and plug in 2 for all the x's and see what you get. All right. So see if you got the right answer. 5, put the 2 in for x, plus 3 times 2 plus 1. 2 squared is 4. 4 times 5 is 20. 3 times 2 is 6. Plus 1. 20 plus 6 plus 1 is 27. And there's my answer. All right. We just substitute it right in. All right. Third example. Limit of f of x. Well, what is f of x? F of x is this piecewise or multi-rule function as x approaches 2. Well, if I look, I have two options. What equation do I plug in? 5x plus 1 or x squared? Well, what is 2? 2 is less than 3, isn't it? So I'm going to plug it into the top one. All right, 5 times 2 plus 1, 10 plus 1 equals 11. All right, so the limit as x approaches 2 of this function is 11. All right, now, piece of cake, right? The problem is we're not always going to be able to use substitution. All right, so what if substitution does not work? Well, the first thing we will then probably try to do is try to do some algebra. Okay, and if possible, all right, now, probably should mention this. Well, how do I know if substitution is not going to work? Well, look at this first example here of the limit as x approaches 5 of x squared minus 25 over x minus 5. If I were to substitute in 5 here, what happens? I get 5 minus 5, which is 0. You cannot have 0 in the denominator of a fraction. So that right there tells you that substitution won't work. So you have to do something else. Now, in this particular example, what we're going to do is we're going to factor. All right. I can factor x squared minus 25 to x minus 5 times x plus 5 all over x minus 5. All right. What happens there is you hopefully notice that I can cancel out the x minus 5s, and I am left with just x plus 5. So now we factored, we reduced. Now let's substitute in the 5. And what's 5 plus 5 is 10. And there's our answer. So when substitution doesn't work, we still eventually do substitute. We just happen to do some algebra first, then go back and substitute. All right, so I get 10. All right, go through the same steps. For this example here, the limit as x approaches 2 of x squared minus 4 over x squared plus x minus 6. And you'll notice you can't substitute because 2 squared is 4, 4 plus 2 is 6, 6 minus 6 is 0. You can't do that. So you're going to have to do some algebra. Go ahead and try that now. All right, so you can factor the top and bottom. X minus 2, x plus 2. The bottom factors to x plus 3 times x minus 2. All right. And you see that the x minus 2's factor. So I'm left with x plus 2 over x plus 3. All right. So now I've canceled things out. Now let's see if I can substitute 2 in there for both the x's, right? I have 2 x's. So 2 plus 2 is 4. 2 plus 3 is 5. All right. So the answer to this one is 4/5. All right. So we factored, we reduced, then we substituted in. All right. All right. Now, next one. All right. The next type is a complex fraction. Well, what is a complex fraction? Complex fraction is we have this for big fraction bar, right? And then we have other fractions within it. That's what we call a complex fraction. Now, looking at this, your first instinct should be to substitute 0 in for x. The problem is I get 0 in the denominator, which means I can't do it. All right, so this is not one where you factor. Whenever you see a complex fraction, we want to simplify the complex fraction. Now, in case you forget how to simplify a complex fraction, what we're going to do, we're just going to multiply everything by a common denominator. Now, the denominators here are x plus 5, 5, and in this case, the denominator for x is 1. So we're just going to multiply those together. But I'm not actually going to multiply. I'm going to write it out as 5 times x plus 5. And what you do to simplify a complex fraction is I multiply this to all 3 terms. And what that's going to do is that's going to get rid of all those denominators, and we're just going to have another fraction. Then we're going to look to simplify and then substitute. All right. So when I multiply 5 times x plus 5 over 1 times 3 over x plus 5, my x plus 5s are going to cancel, leaving with 3 times 5, which is 15. All right. So just so everyone knows what we're doing 3 times x plus 5, and I'm multiplying it by 5 times x plus 5. Right? The x plus 5's canceled. I was left with 3 times 5, which is 15. Now, when I do to this one, the 5s are going to cancel, and I'm left with negative 3 times x plus 5. And then on the bottom, nothing cancels because it was just a 1. I'm going to write 5 times x plus 5. Notice I'm not actually distributing this, and you'll see why in a second. All right, so I'm left with that. Now, I still can't just substitute in 0 because I still get 5 times 0, which is 0. And 0 times 5 is 0. I still get 0 in the bottom. So I need to cancel something out. But watch what happens. Up top, if I distribute that, I get this, which you hopefully notice that the 15s will cancel out, leaving me with negative 3x over 5x times x plus 5. Now, these x's, since they're both on the outside, I can cancel. And I'm left with negative 3 over 5 times x plus 5. Once you cancel something out on the bottom with up top, then check to see if you can substitute in your 0. 0 plus 5 is 5. So, all right, and then 5 times 5 is 25. So my limit, the answer to this problem, is -3/25. All right, so we simplify the complex fraction. Things canceled out. We're able to cancel this x, and that's why we don't multiply the 5x squared plus 5. We keep the x there so it eventually cancels, and this will happen with examples that are like this, similar to this all the time. All right, so follow the same steps we just did and do for the limit of 4x plus 6 minus 4/6 over x. Oops. No, you're good. Okay. All right. So try this one right now on your own. See if you can get the right answer. All right. So let's see how you guys did. You're going to multiply by 6 times x plus 6 because that's my common denominator. When I multiply by the first term here, the x plus 6 will cancel, leaving me 4 times 6, which is 24. When I multiply here, the 6's cancel, and I'm just going to distribute that -4, -4x plus 24. And then I multiply by the bottom, just leave it as 6x times x plus 6. All right. So here, the 24's cancel, leave me with -4x over 6x times x plus 6. The x's then cancel, so it's -4 over 6 times x plus 6. Once it cancels, now we substitute in my 0. 0 plus 6 is 6. 6 times 6 is 36. -4 over 36 reduces to -1/9. And there is my limit. All right. So to recap, you always want to use substitution first when we're doing limits. And there's going to be many examples that are going to do substitution doesn't work. Right now, we've learned 2. All right. You could factor, reduce, and simplify, or you can do complex. You can, if it's a complex fraction, you can simplify it. And what's going to end up happening is we're going to have a bunch of different methods depending on what the problem looks like. And we're going to continue to do this for the next 2 to 3 days. All right. So hopefully you guys understood these first few examples that we went over. And I hope you guys enjoy the rest of your day.